Question says, suppose a car is stuck deep in mud. One method for pulling the car out of the mud could be to attach a rope to a fixed object like a tree trunk and then push on the rope vertically in order to create tension and hopefully accelerate the car from rest and get it moving. So they say, what force would you have to exert perpendicularly here in order to achieve a tension in the rope of 11,650 newtons at an angle of 3.6 degrees? So you could draw a diagram of this rope and then analyze the trigonometry there, the triangles. And they say that this angle's got to be 3.6 degrees and your tension force has to be 11,000. So that is one option. You could analyze like a triangle, find the vertical and horizontal components of that tension force, which could be called Tx and Ty. However, I might use a different approach, which is to make a force diagram for a tiny piece of the cable. And I think it could get kind of confusing doing it this way, but it might be a lot less confusing if you use this method of find a point in the cable that you want to analyze, call it point P, and just draw the forces that would act on that cable. So by Newton's third law, if the rope pulls on the car with a tension force T, then there will be an equal and opposite reaction force acting on the rope. So the rope just transmits a force, and the tension on the left side of it is going to be the same as the tension on the right side of it. So you can use that fact to make a drawing of these tension forces. So there will be a force of tension, basically car on rope. It's called Newton's third law reaction pair. These guys. So I will now draw my diagram for point P. So there's a tension force pointing up and to the right. And then there's another tension force for the other side of the rope pointing up and to the left. And then you also have this vertical push, the perpendicular push of the person. So now you have a diagram that you could analyze forces for, and we want equilibrium for this diagram, so all the forces need to be balanced. That's because at a time when the car is stuck, we have what's called static equilibrium, where nothing's moving yet. Okay, so let's balance the forces. You might take those vectors and find their components. So what that'll look like is this. We'll have Tx, x component of the thing. And then each of them also needs a y component. Ty. The x components are going to cancel out here. All that matters really is the y components. They said that the push was going to be what we're looking for, actually. But we do know the strength of the tension. 11,650. Since we know the diagonal, we can find the components. Your T1y is going to be T1 sine theta 1 T2y is, what's up? T2 sine theta 2. So because of a thing called alternate interior angles, this angle here is going to be the same as this angle, and this angle here will be the same as the other one, the corresponding angles they're called. Okay, so we'll do this.
Yeah. I told him as much as I understood about it yesterday.
731.5. This one's also going to be the same.
I shared those conversations with him.
Okay.
Yep, indeed.
Okay, so now what we're going to do is figure that the y forces have to be balanced. So this push just has to equal the sum of those two components. You could write it formally like this, that the sum of the forces in the y direction needs to be 0 for equilibrium. So T1y plus T2y. So you do this. $14.63. And that should be my answer. I'll check it with the program. Yep, it agrees. Does that make sense? Okay, so part B says, under such a large force, let's say that the cables get stretched significantly, what force would be exerted on the car if the angle were to increase to 7 degrees, but you're still applying the same force that you found in part A? So I'll draw another diagram. Alright, so now my force of push remains 1463. But we have a new angle of 7 degrees. Basically, we need to sum the y forces once again with the new numbers. So, sum of the forces in the y direction will be basically 2 times the y component of t minus 1463. This has to equal 0, so when you rearrange, you're going to get that 2ty has to equal 1463. You'll divide by 2, get that ty is 731.5. So now you know this. You have one of the legs of a triangle and the angle of the triangle. They're asking us for the tension, what force would be exerted on the car. So that's gonna be the size of the diagonal, because the diagonal is the tension force T. So just use a little trigonometry. SOHCAHTOA. I would go with sine being the opposite over the hypotenuse would be the best one to use instead of cosine, and I wouldn't use tan here. I would use this one because we have the opposite, we want the hypotenuse, and you have the angle. So $6,002 newtons. So quite a bit less force. When the rope is stretched like that. Because before it was 11,000.